Hello, in this video we will discuss about the measures for linearity in the sweep time-based waveforms. So in the previous video we have seen this is exponential sweep circuit and this is the waveform generated by the exponential sweep circuit. Switch is kept open between 0 to ts seconds and this portion of the waveform is generated for ts seconds, and we are going to check linearity of the waveform, and that linearity can be measured using slope error, displacement error and transmission error. Coming to slope error, we have roughly seen Ts by Rc, transmission error is Ts by 2 Rc, displacement error is Ts by 8 Rc. Now we will go with how to derive expression for these errors, for these measures of linearity for sweep circuit waveforms. First measure is slope error or sweep speed error, and coming to the waveform, we have the initial slope minus final slope divided by initial slope. In the waveform, initial slope minus final slope divided by initial slope. This is the output equation. We will make first order derivative for this. Substitute t equal to 0, t equal to capital Ts, and analyze what will happen. This is the derivation for the equation. So first term is constant, derivation is 0, minus second term v into e power ax is e power ax into a. So e power ax into a value is minus 1 by Rc. If we simplify this, minus into minus becomes plus, v by Rc into e power minus t by Rc. Now substitute t equal to 0, it becomes v by Rc, that becomes initial slope v by Rc, initial slope is v by Rc. When you substitute this t value, Ts, capital Ts, that is switch kept open for ts seconds, that becomes final slope. So everything is same except the small t is changed to capital Ts. Now if we simplify, numerator v by Rc can be taken common, it gets cancelled with denominator v by Rc. Finally we are left out with 1 minus e power minus Ts by Rc. E power minus x, if we expand, it becomes 1 minus x plus x square by 2 plus x cube by 3, etc. Higher order terms we can neglect in order to, as the value goes lower, higher order terms can be neglected. It doesn't give much effect, and we are expanding this exponential e power minus x, we are getting this, and on simplification 1 minus 1 will get cancelled, so minus into minus will become plus. So first term will be Ts by Rc, second term will be minus Ts by Rc whole square into half. And if higher order terms are neglected from second order onwards, if higher order terms are neglected, then we are left out with Ts by Rc. This becomes sweep error. This is first method of getting expression for sweep error. If we go to another method, this is the output equation in the sweep circuit, exponential sweep circuit. At Ts, the capacitor is going to get charged to a voltage of Vs, and if we substitute this t equal to Ts in the first equation, it will become V into 1 minus e power minus Ts by Rc. If we expand this exponential e power minus x as 1 minus x plus x square by 2 factorial and so on, and here on simplification it will become V into Ts by Rc. This 1 minus 1 gets cancelled, so minus into minus will become plus, plus Ts by Rc, and from square second order terms we are neglecting all the second order, third order, from there on all the terms are neglected, and now we are having Vs equal to V into Ts by Rc. We know that the fraction Vs by V is nothing but sweep error, so Vs by V is nothing but sweep error, that is equal to Ts by Rc. This is second method of getting expression for sweep error. Now we will go with transmission error. This is the waveform. we are trying to transmit a ramp type of waveform. Input is ramp type, but during transmission the waveform gets distorted, so this is the distorted waveform, output waveform. Input is straight ramp waveform, output is this distorted waveform. Transmission error is nothing but input minus output, difference between input and output, divided by input waveform at the end of the sweep, input waveform amplitude at the end of the sweep. This is the formula for transmission error. And now if we take the output equation, V is equal to V into 1 minus e power minus t by RC, and now substitute t equal to Ts in this equation, we are going to get output voltage as Vs. In the graph it reaches Vs level, so Vs becomes Vs, and that is when t equal to Ts we are just substituting. And here again expand e power minus x, this will be 1 minus x plus x square by 2 factorial and so on. On simplification we will get, if third order and higher order terms are neglected, first order and second order terms are maintained, then this will be the simplified. 1 minus 1 gets cancelled, plus Ts by Rc, and then again plus this minus into plus will become minus, minus Ts by Rc whole square into 1 by 2 factorial is 2. This is Vs value. Initial slope already we calculated in sweep error, it is V by Rc. And now if the initial slope is maintained at t equal to Ts, then the output waveform Vs dash will be Ts into that initial slope. If the slope is maintained at Ts time, then output Vs dash will be Ts into initial slope. So now the formula is initial transmission error, the formula is actual input, the ramp type input minus distorted output divided by input. This is ramp type input minus distorted output divided by input. So we have calculated Vs distorted output in this equation, and then actual input, this is the equation Ts V by Rc, and denominator also the same, actual input. So this is our input, this is our distorted output divided by this input. So we have substituted. On simplification these two terms will get cancelled, we are left out with plus V by 2 Ts by Rc whole square. So V will get cancelled, one Ts by Rc also will get cancelled, so numerator we are having Ts by Rc, and this 1 by 2 is left out. So here we are calculating transmission error. We got sweep error Ts by Rc, transmission error we are getting Ts by 2 Rc. So this is half of the sweep error. So transmission error is half of the sweep error. Next we will go for displacement error. This is the actual sweep and this is the linear sweep. So the formula for displacement error is difference between actual sweep and linear sweep divided by the amplitude at the end of Ts. Numerator is actual sweep minus linear sweep divided by at the end of Ts what is the amplitude, Vs. This Vs at the end of the sweep. This is the formula for displacement error. If we take at Ts by 2, at time Ts by 2, if the actual sweep, so Vs by 2, if we see here at Ts by 2, we are substituting in this equation, so time equal to Ts by 2, we are substituting time equal to Ts by 2. If we expand this e power minus x, so 1 minus x plus x square by 2 factorial and so on, and if we simplify this 1 and 1 get cancelled, Ts by 2 Rc, next term is minus Ts by Rc whole square into 1 by 8. So here 1 by 2 whole square will become 1 by 4 into 2 will become 1 by 8. Higher order terms are neglected. This is at Ts by 2 the value of output Vs. Next, at TS we are again taking the output equation and we are substituting t equal to Ts. And if we expand that, e power minus x, 1 minus x plus x square by 2 factorial and so on. If we simplify, this 1 and 1 will get cancelled, Ts by 2 Rc, and then minus 1 by 2 Ts by Rc whole square. This is the output value at Ts. This is the output value at Ts by 2. Now our displacement error is Vs minus Vs dash divided by capital Vs. If we see here, this capital Vs is at Ts. Capital Vs is at Ts. So denominator we are taking this part. So numerator, if we see, numerator it is Vs minus Vs dash. So this Vs we are calculating here. So which is V into Ts by 2 Rc minus Ts by Rc whole square 1 by 8. So 1 by 8 Ts by Rc whole square. This term Vs, and Vs dash is nothing but V by 2 Ts by Rc minus Ts by Rc whole square half. So whatever denominator is there divided by the 2 is Vs dash. We see the previous slide. So Vs dash is Vs divided by 2. So Vs we are calculating here. So whatever we got here divided by 2 is nothing but Vs dash. So the same denominator we are taking this. Numerator first term is this. Numerator second term is denominator divided by 2. So denominator divided by 2 is numerator second term. Numerator first term is Vs and denominator is Vs. If we simplify this, the first term will get cancelled. V into Ts by 2 Rc, V into Ts by 2 Rc will get cancelled. Other two things if we see, here it is minus 1 by 8 V into Ts square by 4 Rc square. 4 into 2 is 8. And then here minus into minus will become plus, and Ts square by 2 Rc whole square. We are taking 1 2 common, so this 2 into 2 will become this 2 into 2. Denominator if we see, if we neglect higher order terms, only first term we are taking V into Ts by Rc. If we simplify this further, numerator both are same terms, only this is 1 by 2, this is minus 1 by 4. So we will get plus 1 by 4 in numerator, plus 1 by 4 Ts by Rc whole square in numerator. V and V will get cancelled, so numerator will have 1 by half, denominator only Ts by Rc. Here 1 Ts by Rc will get cancelled, so only 1 Ts by Rc is there. 1 by 2 into 1 by 4 becomes 1 by 8. So displacement error we are getting Ts by 8 Rc. Sweep error is Ts by Rc, displacement error is Ts by 8 Rc. Hence it is 1 by 8 times of sweep error. Displacement error is 1 by 8 times of sweep error. Now if we see displacement error into 8 times becomes sweep error, and transmission error is Ts by 2 Rc. So sweep error is Ts by Rc. 2 times of the transmission error will become equal to sweep error. These are the relation between displacement error, sweep error and transmission error. This sweep error, transmission error, displacement error. Just by making LCM in order to remove the fraction to make it a full numbers, another representation is this. In general, sweep error is Ts by Rc, transmission error is Ts by 2 Rc, and displacement error is Ts by 8 Rc. Thank you.